So we've all heard the old adage, horses for courses, meaning that different people have different strengths and preferences. And we see this in elite athletes and their chosen sporting disciplines. And each discipline has specific requirements. For example, sprint performance requires a greater proportion of type 2 fast twitch muscle fibres for short, powerful bursts of speed, whereas stamina athletes need more slow twitch muscle fibres for sustained movement and resistance to fatigue. These same principles apply to racehorses, with different racehorses being better adapted to different racing distances and categories. So currently, we can tell a little bit about where a horse's strengths may lie based on their body type and their pedigree. So are they compact and muscular, which would suggest a sprinter, or long and lean like our marathon runner? And where are the parents successful? But this has obvious limitations, as even full siblings can have vastly different aptitudes. I can certainly see this between my brother and I, who have same body type, same pedigree. He's ace at tennis. I look like a kid trying to hit a piñata. So how am I going to achieve this? Well, in my PhD, I want to look at what is going on under the hood of these racehorses at a molecular level. So we can apply the same principles used in human exercise science and testing to the racehorses. So as each of the racehorses are put through their paces, we can take measurements of speed, heart rate, oxygen consumption, and muscle function to get an indication of an individual's aptitude for speed, their aerobic capacity, and their overall fitness. We can also take these measurements over time and see how they change with the age and training of each horse, giving us an idea of when a horse may reach its peak performance and how different horses will respond to training. The next step is to compare the letters of each horse's genetic sequence with our exercise measures to see if we can decode which letters of the DNA sequence spell out different exercise traits. Then, using computational technology, we can try and make predictions based on a horse's genetic sequence about where its strengths may lie. So, is it destined to be an elite sprint performer and win at an international level? Or will it have a great aerobic capacity, suggesting a greater aptitude for stamina performance? And which, quite frankly, are going to be the couch potatoes. So my research will help enable owners, breeders and trainers to make more scientifically informed decisions about the aptitudes of their horses. The thoroughbred industry is a multi-billion euro global industry in which Ireland is third in the world. Woo, go Ireland. And with the help of my PhD, I hope that each horse can be raced and trained to the maximum of its potential based on what is written in its genes. Thanks very much.